Hello, hello. Hello, everybody, for another unexpected live event. I don't know how many we are on LinkedIn and YouTube. Okay, let's take a few minutes to see how many people come on a Sunday night. Otherwise, I will just make a live next week. Feel free to say hi in the comment section. If you are here, I have no idea how many people are on live right now, but I'm super excited to see you for this quick video. The idea again is to review a data engineering project. Again, I actually don't schedule those live events. Maybe I should, but for now, I just want to keep them very informal. And whenever I see a data engineering project that I think might be interesting for you to to look at, or at least like where you can learn things out of it, I will make a live though. So that's really the idea here. So again, feel free to say hi in the chat wherever you are on YouTube or on LinkedIn. But let's take a look at this pipeline. So again, like if you want to find data engineering projects, you can go to Data Project Hunt. But we have this pipeline, which is data warehousing for real-time pipelines, which is about building a real-time data warehouse with the use of state-of-the-art tools like Kafka and other tools. So just to keep in mind, I have no idea what this project does. I didn't check it before going live. So I'm going to discover this project with you guys. So let's see what it is. We have this image of the architecture. So it looks like it pulls data from a financial institution. I don't know if that's real data. I guess not. Might be CSV. We'll see. And then it uses Airflow for processing the data, I guess. And then there are like some streaming to Pinot, Redpanda, and then the data is fetched from Superset, Streamlit, and Elasticsearch. I don't know if you know, I actually haven't used Pinot and Redpanda before. I know those tools, but I've never used them. And Superset is really cool for dashboarding. Streamlit, it's more like for data apps. And then you have Elasticsearch, which I guess you may know because it's about finding, interesting data in your, in your data. I'm not sure if that was the nice way to say it. Anyway, so let's take a look at about this project. We have the introduction here. So in today's fast-paced world, decision-making can't wait. Okay, businesses need to react instantly to changing situations. Blah, 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 blah. This is where real-time data warehousing comes into play, enabling businesses to make decisions based on what is happening right now, rather than an outdated information. What I find interesting in this project is you cannot use Airflow for real-time processing, as you know, right? Today, there is no way to use Airflow for real-time processing. It's still batch processing. So I wonder, like, how, like, what Airflow plays here in this architecture, because if everything is supposed to be real-time, then how can we use Airflow for that? Okay. All right, so without further ado, let's take a look at the project on GitHub. Again, I'm not going to run this project, but feel free to take a look at it and run it by yourself if you want to see, if it works. But what I'm going to do right now is to review the DAG, because that's what I'm an expert on, is Airflow. But if there are like experts in the audience right now that know, other tools that this project use, feel free to share your insights in the comments. I would love to learn about what you think how those tools are used in this project. Okay, so let's take a look at the Git repo. We have the tech stack. So in this project, we will be leveraging the following key components. We have Airflow, nice. We have Redpanda, which is a Kafka compatible distributed streaming platform optimized for lower latency, blah, blah, blah. We have Pinot, which is a real-time distributed OLAP data store designed for low latency analytics on event streams. And then we have Superset and Docker. So it looks like the platform runs on Docker, which is pretty cool to see. But that being said, I highly recommend you to, whenever you publish a project, like a data engineering project, I highly recommend you to at least show the instructions to run the project in local, because otherwise it's going to be, it's not very convenient for anyone else to actually try your project. So I understand that, when we build a project, it's for us, but when you publish that project, you expect that others will try it. And so make sure that you have the instructions to run your project in local, because right now there are no instructions. I have no idea how to run this project in local. I mean, obviously I guess it's going to be Docker, because we can see Docker here, and there is a Docker file, a Docker compose file right here. But again, it's always nice to have the instructions to follow to run a project. Okay. All right. So let's take a look at the DAGs right now. Actually, before doing that, I'm going to look at some of the files here. Maybe we can find the Airflow version used. Okay, so it's 2.7.1. So that's a pretty old Airflow version. And also it looks like, it's a mixed, this Docker compose file has some services to run Kafka and so on, but you will find those settings in the official Docker compose file of Airflow. So I guess the author made a mix between the official Docker compose file, Airflow Docker compose file, and other services that the project needs to run. I'm pretty sure of that. By the way, in Airflow 3, the Airflow web server service does not exist anymore. It's the API server. So just for your information, the API server still serves the user interface, but it does more than that. That's why we call it API server. It's because now you can have this API server that actually allows your workers, for example, to run somewhere else, and then you can still execute your tasks through your workers by using this API server. Okay, so let's take a look at the DAGs right now. Okay, so what do we have here? Okay, we have many Python files. Actually, this project is 2 years old, so that's pretty old. I guess maybe at some point I will add, I don't know what you think about that, but I will add a freshness info here for the project. But let's take a look at those files right here. So what do we have? We have the loader DAG. So I guess that's the first DAG that runs for loading the data. Okay. So keep in mind, it's a pretty old Airflow version here. It's 2.7. But the first thing that you notice is the imports at the top of the file. So you don't have to, it's up to you if you want to use the DAG object, but you have the DAG decorator that you can use as well. To import the DAG decorator, you have to use airflow.sdk if you are on Airflow 3. If you are on Airflow 2.7, then it is still airflow.decorators. Okay. Then you have the Airflow operators bash and the bash operator. Again, you have the decorated version for the bash operator. So instead of using the bash operator, you can use the @bash decorator, which works like the bash operator, but in my opinion, it's better because you have the flexibility of Python, and then what you return from the bash decorator, it's going to be the command, the bash command that you want to run. But before returning that command and executing the bash command, you can add some Python logic. Okay, so you have more flexibility by using the bash decorator, the @bash, than the bash operator. Okay, so that's actually I can show you that. So if we look for bash decorator, I'm not sure if we're gonna find it here. Yes. So that's what I was saying. you see you have the @task.bash. And what you can do here is you return the bash command that you want to execute, but in between the name of the function and what you return, so the bash command you want to run, you can add some Python logic. Okay, so this is more powerful because you can execute different bash commands according to some according to different logics. Okay, so that's why I highly recommend you to try the task bash over the bash operator. It's more flexible, more powerful in my opinion. Feel free to tell me what you think in the chat. By the way, you can comment. I can still see your comments, I guess. Okay. All right. So let's go back to the DAG. So we have the usual from datetime, time delta. Okay, why not? So I mean, this is a pretty old way of defining DAGs. I don't know about you, but when I started with Airflow, I've always found DAGs defined like that, where you have at least the default args defined outside of the DAG object. And then you have default args equals to default args, exactly like that. The truth is, most of the time you won't have to, I mean, most of the time the default options, okay, for your tasks will be enough, right? Like most of the time you won't have to change your default arguments for your tasks. Remember that what you see here, default arguments that you can see here that are set at the DAG level apply to the tasks, okay? So when you say like depends on past, backfill, and start date and so on, like all of those parameters are actually applied to all of your tasks, okay? And not your DAG. But anyway, you can still define your default arguments if you want like that, but most of the time you don't have to, unless you want to change the default values, obviously. So we have the start date defined like that. Why not? I mean, it's up to you. You define it how you want. We have the DAG object, so the DAG ID, because you use the context manager with, you have to define the DAG ID like that. But if you use the DAG decorator, then you don't have to do that. Okay, with the DAG decorator, you don't have to define the DAG ID like that, because the DAG ID will be the name of your function that corresponds to your DAG. Okay. So again, like if you don't know, if you know nothing about the DAG decorator, try it. You will see how it works, but just keep in mind that you don't have to define the DAG ID if you use the DAG decorator. Then we have the description, always a good idea. The schedule interval. So actually the schedule interval, this parameter, was deprecated before 2.7, I believe. Okay, you should not use schedule interval anymore. You should use schedule. Okay, schedule only. Why? Well, because Airflow has more than just time to schedule your DAGs. Okay, in fact, there are many different ways for scheduling your DAGs in Airflow. You can schedule your DAGs on time, but you can also schedule your DAGs on data updates, or you can schedule your DAGs on events, right? So there are like 3 different ways for scheduling your DAGs at least, and it's not on time only. So that's why it's not an interval, like it's not schedule interval anymore, it is schedule, okay? And then we have catch up to false. Catch up to false, always a best practice. So it's nice to see that here. In Airflow 3, you won't have to set schedule catch up to false anymore. It is by default. Okay. I'm not sure if you can see my screen clearly. So let me know in the chat if you can't see my screen clearly right now. I have no idea. Okay, then we have the bash operator. So you can see here we have like 3 tasks using the bash operator. I don't have anything to say here. You can do that. What I would add maybe is, you know, when you have like a bash command, actually one thing you can do is to put your bash command in a separated file. So instead of having your bash command like that, you put it in a different file, like my command.sh. Okay, and that's better, because if you have like long bash commands or even like SQL queries and so on, it's always a best practice to separate your queries, bash commands, bash scripts, and so on in separated files, okay, than having everything in your single DAG file, because otherwise your DAG file is going to be huge at some point. And you want to avoid that. Okay, you want to avoid that. So to avoid that, you can create again like bash files. I mean, files where you put your bash commands, and then you import those bash or those files, and you run your commands like that. Okay. Same thing for your SQL queries. It's even more important for SQL queries because SQL queries tend to be much bigger than bash commands. Okay. And again, I would use the bash decorator instead of the bash operator here, just because it's way more straightforward to write to create. Okay, so that would be my feedback on this DAG is use the bash decorator instead of the bash operator, and import the bash commands instead of hard coding them right now in the DAG file. Okay. If you have any insights, feel free to share as well. Like if you think we could change a few things here, other things here. So let's take a look at the other DAGs. There are many DAGs, so I'm not going to go over all of them. I'm just going to check some of them. So let's see what we have here. Okay, that's a pretty long one, but it looks pretty simple. So I guess this one, and again, I'm discovering the DAG exactly at the same time as you. So we can see that this DAG is using pandas. Okay, so I guess like for processing some data. Yeah, so here the idea is to generate some random data, and then we create a data frame, blah, 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 and we store the data in a CSV file. Okay, so that's pretty classic. Again, same feedback as the previous one, the schedule interval. The use of tags is a good idea. You should always define tags to your DAGs, because remember that with the tags, you can categorize your DAGs on the Airflow UI. You can filter your DAGs on the Airflow UI, so you will save a lot of time if you define tags, especially if you have many DAGs. You want to do that. It's always the best practice. For the Python operator, it's up to you, but you also have the task decorator, which is the equivalent of the Python operator. And again, in my opinion, it's better to use it over the Python operator. Okay, why? Because it's straightforward to write, to read, and to debug. So I highly recommend you to use the task decorator over the Python operator. And the use of the empty operator, why not? The good idea here is to use the empty operator and not the dummy operator. If you are still using the dummy operator, remember that this one has been deprecated a long time ago. Okay? But otherwise, I don't have anything to say. I mean, I think it's a, I mean, yeah, I don't know if you should use pandas directly like that. You can, but it looks like to be a toy example here. So I don't have anything else to say on that DAG. Let's see what else do we have. Table creator DAG. That one might be, yeah. So similar than the other. I guess like all the DAGs are gonna look the same, right? Yeah, you see, you always have like. So I wonder why the author created a start and an end tasks. Maybe because a single task in a DAG doesn't look good. But truly, I mean, there is no. It's not bad to have a single task in your DAG. Okay, so you don't have to absolutely have more than one task in your DAG. That's okay. It's funny to see a start and an end. That being said, actually, that makes me think about if you don't know about the setup and teardown tasks. So imagine that here, instead of a Kafka produce operator task, you have like a task that creates a cluster, a EMR cluster, and you want to ensure that this cluster is created first, and then this cluster is going to be deleted, removed after having used it. In that case, you should use setup and teardown tasks. So if you don't know about setup and teardown tasks, I highly recommend you to look at that. So teardown tasks, Airflow. So setup and teardown are super useful whenever you need to create a resource. So that's what you can see here. Use it to do some work and then tear it down. Okay, so if you want to ensure that your cluster is always deleted, always removed, regardless of what happened in the previous task. So imagine here, run query fails. Okay, you want to ensure that delete cluster still runs. And that's exactly what's going to happen if you use setup and teardown tasks. Okay, the setup task will be the create cluster, and then the teardown task will be delete cluster. And regardless of what happens in run query, delete cluster will be always executed. So the idea of setup and teardown tasks is to ensure that you manage your resources properly in your workflows. And this is a super convenient feature that I think a lot of people don't know about. Okay. So feel free to take a look at setup and teardown. It's super useful for that. And yeah, so when you do a start and end, that might be a good use case for that. All right, so let's go back to some of the DAGs. Here we have the branch dim generator. Did I already check this DAG? Yes, I think so. It's pretty late here. What else do we have here? Maybe this one. Yeah, okay. I mean, they all look the same. Speaking of that, when you have DAGs that look pretty similar, I highly recommend you to actually have a template. Okay, so you have like the structure of your DAG, and then you have a configuration file with different settings that you will go over in order to generate the number of DAGs that you need. Actually, you see customer dim generator, and branch dim generator and account dim generator. So instead of having 3 times the same DAG, or 4 times actually, maybe 3 times. So you have the account dim generator, branch dim generator, and custom dim generator. So instead of having 3 Python files like that, which are exactly the same, but just the settings are different, just create one Python file with the structure of your DAG. Use Jinja if you want, the Jinja templating engine. So use Jinja if you want, and then generate a DAG or generate one DAG for every setting that you have. Okay, for every configuration setting that you have. So here, for example, it could be for every table. Okay, so you have in a file, you have your 3 tables with some settings for each table, and then you go over your configuration file and you generate the corresponding DAGs for every table. Okay, so one for dim generator, one for one for account dim generator, one for branch dim, and one for customer dim. Okay, this is actually a very, very common practice, and I'm pretty sure that you already know that. Okay. All right, I think I think that's it for this. But interestingly, we have the settings here. Okay, you see we have the schemas and tables. Okay, so I think that's all I have to say for this DAG and for this project. There are other projects that I think are super interesting to take a look at. I will look at that later, and I will schedule a proper live. Right now, I'm just going live at whatever time it is. But there are other super interesting projects right now on data project, and I'm super excited by that. There is this one, the Airflow medical data pipeline, the Blue Sky NBA real-time sentiment analysis that I would love to take a look at. Some very, very interesting projects. And by the way, just to answer the question, about the fact that this project is real-time and still using Airflow for a real-time project. So I don't think this is actually real-time. I think Airflow right now is used for pulling the data and then sending the data into Pinot and Redpanda. So this is done in batch. Okay. So it's not truly real-time, obviously. All right, so that's it for this live. I hope you enjoyed it. I have no idea how many we are today, but again, it was a very unscheduled, informal live. I hope you enjoyed it, and I see you for the next one. Take care. Bye.